NASA's Voyager 1 probe, which presently holds the title for the most distant object ever created by humans, has captivated individuals worldwide for almost 5 decades. Since its deployment, Voyager 1 has transmitted crucial information from the farthest reaches of outer space, enhancing humanity's comprehension of the cosmos. Nonetheless, the probe's recent broadcasts have experienced unusual irregularities that have left experts baffled. These enigmatic signals have sparked vigorous debate, prompting the scientific world to wonder whether these oddities are mere technical glitches or indicators of something far more astonishing, potentially even alien involvement. Join us as we delve into these bewildering messages and examine what might be concealed in the boundless expanse of the universe. The innate human urge to uncover mysteries has long fueled our pursuit of space exploration. This profound inquisitiveness paved the way for bold initiatives such as Pioneer 10 and Pioneer 11, which ranked among the most courageous space endeavors of their time. On August 20, 1977, the launch of Voyager 2 from NASA's Kennedy Space Center initiated a groundbreaking era in space research. Soon after, on September 5, 1977, Voyager 1 was sent into space, beginning a voyage that would lead it to the outer planets, dramatically altering its route and scientific outcomes. Each probe, with a mass of around 721 kilograms, comparable to a compact automobile, ventured in distinct directions at differing velocities. On December 15, 1977, an important achievement occurred when Voyager 1 outpaced its twin in terms of distance covered due to their divergent paths. Since then, Voyager 1 has served as a vital asset in deepening our perception of space, supplying discoveries that have changed how we understand the universe. Before diving into some of its recent revolutionary findings, let's revisit several of its earlier key accomplishments. In 1979, positioned roughly 265 million kilometers from Earth, Voyager 1 obtained high-resolution photos of Jupiter. By January of that year, it had finalized an impressive 100-hour study, resulting in a time-lapse sequence that portrayed Jupiter's rotation. This set of 3,750 images delivered unmatched insights into the planet's turbulent atmosphere and complex features. During this expedition, Voyager 1 also detected a previously unidentified ring around Jupiter and found 2 unknown moons, greatly improving our knowledge of the gas giant's intricate system. To maintain its trajectory and avoid crashing into Titan, one of Saturn's moons, the probe executed several navigational adjustments. Following this, the mission turned its attention past the solar system's planets as the spacecraft was rerouted into interstellar territory, traveling at an extraordinary pace of 325 million kilometers per year. In January 1990, Voyager 1 began its assignment to investigate interstellar space, pressing onward beyond the limits of our solar system. During this phase, it accomplished several exceptional feats, such as identifying 4 new moons, Memes Enk, Enceladus II, and Rhea, and capturing some of the most memorable snapshots of the solar system's outer boundaries. On February 14, 1990, located approximately 6 billion kilometers from the Sun, Voyager 1 took the iconic family portrait, a panoramic collection of images of the inner planets. This compilation of 60 photographs was added to the probe's extensive gallery, which already featured hundreds of images from its close encounters with the gas giants. Voyager 2, in parallel, marked remarkable achievements during its journey. It measured wind speeds on Neptune that topped 2,100 km/h, roughly 1,300 meters per second, the swiftest atmospheric currents ever recorded in the solar system. It also observed Triton, Neptune's largest satellite, where temperatures dropped to a chillingus 391 degrees Fahrenheit, ranking it among the coldest known lochs. Triton showed signs of icy eruptions, spewing nitrogen gas and frozen debris up to 5 kilometers high, revealing fascinating new aspects of its geology. These phenomenal findings significantly broadened our grasp of the varied and vibrant conditions in the solar system's outskirts. The impact of both Voyager 1 and Voyager 2 has been truly transformative. Their discoveries unveiled previously hidden characteristics of Jupiter and Saturn's moons, once thought to be inactive. This new evidence redefined beliefs about their geological activity. Voyager 2 in particular made history as the only spacecraft to date to pass close to both Uranus and Neptune, an unparalleled accomplishment. NASA used a series of creative tactics to extend the lives of these path-breaking missions, such as powering down non-essential components to conserve energy. The endeavor is projected to continue until 2030, symbolizing the conclusion of a remarkable chapter for the teams who devoted themselves to this mission. The construction of Voyager 1 and Voyager 2 exemplified advanced design and engineering built to rotate slowly. These probes minimized motion blur in their images during travel. Even before arriving at the outer planets, the spacecraft began relaying detailed visuals of Jupiter, unveiling its swirling clouds and the well-known Great Red Spot, a colossal storm that has piqued scientists' interest for decades. One of the most thrilling discoveries was the detection of active volcanoes on Jupiter's moon Io. The instruments aboard the spacecraft picked up peculiar readings from the moon, later validated by pictures revealing massive volcanic plumes and a violently reshaped surface. One eruption on Io was found to be 1,000 times more forceful than Mount St. Helens, blanketing an area nearly the size of France. As their voyages continued, both spacecraft were gradually powered down to save fuel before heading into interstellar territory. Strikingly, they didn't capture images of Mercury or Mars due to technical constraints. NASA later launched additional noteworthy missions, including Pioneer 10, Pioneer 11, and New Horizons on February 17, 1998. Pioneer 10 overtook Pioneer 11 to become the most remote probe from Earth. Despite this, Voyager 1 pressed on for another 14 years before officially entering interstellar space on August 25, 2012. A key contributor to these mission successes was the strategic use of gravitational slingshot maneuvers, which catapulted the spacecraft toward their targets while saving fuel. Instead of relying solely on engine power, they used planetary gravity to boost speed and change course. This allowed them to traverse enormous distances with minimal fuel consumption. As Voyager 1 neared Jupiter, the planet's powerful gravity accelerated the spacecraft. Pinpoint accuracy was vital to prevent dangerous shifts in speed or direction. These gravity assists enabled the probes to skillfully navigate the solar system. Voyager 2 likewise used gravity from Jupiter and Saturn to propel itself toward Uranus and Neptune, proving the effectiveness of the method. Looking back at these extraordinary missions, the scientific community eagerly anticipates new insights from the strange signals recently detected by Voyager 1. These probes continue to operate beyond the outer boundaries of our solar system, investigating the secrets of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse sequences vividly documented 10 eruptions on Jupiter and revealed new satellites and a previously unnoticed ring encircling the planet. These breakthroughs substantially advanced our understanding of the Jovian system. Likewise, Voyager 1 identified 4 additional moons of Saturn: Memes, Enceladus, Tuz, and Rhea, while also delivering breathtaking imagery of the planet and its rings, shedding light on its complex structure. The mission's excursions to Uranus and Neptune generated essential data about their atmospheres and satellites, enriching our comprehension of the solar system's far reaches. After completing their planetary flybys, both probes aimed for interstellar space, where they persist in gathering valuable data. This continuing research broadens our perspective on what lies beyond our solar system as we await further revelations regarding Voyager 1's strange transmissions and their implications for our grasp of the cosmos. The incredible odysseys of these probes continue to motivate both scientists and space enthusiasts around the world. Their achievements remain instrumental in expanding humanity's knowledge and extending the frontiers of space science. The Voyager programs have provided us with unparalleled views of the solar system and far beyond, delivering iconic pictures and scientific findings. Along with these discoveries, the spacecraft also carry a symbolic message, an artifact designed to share Earth's story with possible extraterrestrial intelligences. The Golden Record includes greetings in 55 languages, music from different cultures, and natural sounds like thunder and whale calls. This interstellar message in a bottle expresses humanity's hope that intelligent beings beyond Earth might someday discover and understand it. Voyager 1 and 2 were fitted with a suite of scientific tools that dramatically improved our space knowledge. These included magnetometers, plasma wave sensors, and imaging devices, all of which offered key insights into space conditions. The magnetometers helped decode the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, illuminating how these fields interact with their environments. Plasma wave detectors explained how solar winds affect planetary atmospheres. One of the mission's most notable triumphs was mapping the heliosphere boundary, a region filled with solar particles and electromagnetic fields enclosing our solar system. As Voyager 1 neared the zone, it sensed a shift from solar wind to interstellar matter, yielding crucial information on how this boundary shields Earth from cosmic radiation. The spacecraft identified a definitive point known as the termination shock, where solar winds decelerate and thicken beyond. That lies the heliosheath, where solar and interstellar particles collide, forming a vibrant and dynamic setting. Voyager 2's voyage added extensively to our grasp of the outer solar system. Its pass-by of the giant planets offered important observations, especially of Uranus's magnetic field, which turned out to be angled in a way that defied existing models. These findings have encouraged more study into planetary magnetism. These efforts have not only propelled scientific understanding but also energized public interest in space exploration. The stunning visuals of remote planets and the compelling narratives behind the missions have sparked inspiration across generations. The striking pictures of Saturn's rings and Jupiter's volcanic moons have become iconic, motivating new scientists and space pioneers as the Voyager crafts continue to relay extraordinary data. Their ongoing exploration of interstellar space presents unmatched chances to grasp the very fabric of the universe. Though focus has often centered on planets within our solar system, studying interstellar regions has revealed unexpected complexities. Regions once seen as barren now display intricate phenomena that challenge current science. Among the most intriguing findings is the detection of cosmic rays from outside our solar system. These highly energetic particles, moving nearly at light speed, offer hints about activity in far-off parts of the galaxy. By analyzing their energy and composition, researchers aim to better understand the mechanics of distant star-forming regions and galactic dynamics. Furthermore, as Voyager 1 and 2 journey deeper into interstellar space, their instruments continue to assess the density and motion of the interstellar medium, the matter between stars. This medium, made of gas and dust, interacts with solar wind and influences the heliosphere's shape. As the probes travel through it, they send back key data that helps scientists model how energy and matter behave in the vast stretches between stars. In addition to these studies, the Voyager crafts have revealed much about magnetic fields in interstellar space, offering details about their nature and influence. These insights may eventually lead to breakthroughs in understanding cosmic magnetic forces across galaxies. This continued exploration of space's distant boundaries not only extends our scientific knowledge but also inspires upcoming generations of space researchers and engineers. The unforgettable images captured by Voyager, especially the renowned pale blue showing Earth from over 6 billion kilometers away, remind us of our tiny place in the cosmos. These visuals, together with the scientific advances achieved, have deeply affected how we perceive our planet and its role in the universe. The success of the Voyager missions has opened doors to even more ambitious projects, with the innovations developed during their journeys sending advanced probes to far-off regions of space is now increasingly realistic. Missions targeting exoplanets, the hunt for livable worlds, and interstellar travel are evolving from mere dreams into viable goals for the future of space discovery.